Analysis and redesign of a hand drill by Team 13 with Marcus, Nathan, Michael, Zayed, and Albert. Starting with some background, you can see the drill there on the right in an isometric view. This is a manual hand-cranked drill where the drill chuck itself is loosened, a bit is placed into the chuck, and then the drill chuck is tightened, and then drilling can occur by twisting the crank. Depending on the bit, it can be used for wood, metal, or plastic. Similar products range from $20 to $25 on Amazon, but this is including the bit sets. As far as production volume, there's an estimated 70 to 100,000 based on Amazon yearly sales. Primary customers would be homeowners with limited craft experiences who are looking for safer, less scary, and less expensive alternatives. Secondary customers could be craftsmen with limited electricity access or the need for a lightweight backup drill. Here you can see the CAD assembly with the isometric view, but also top, bottom, and side views. Here you can see the exploded CAD where we have bottom, top, side views as well as the isometric view showing all of the parts.
Our main function of a hand drill is to create holes, and sub-functions include general rotation motion, control operation, remove material, assure dependability, assure safety, and please sense. In our first assembly sequence, the drill machine body is placed first, and then large handle, medium handle, bevel gear housing, small handle, and spindle are assembled in that order. In second sequence for assembly, bevel gear housing is placed first instead, and it expands from there. Bevel gear, drill machine body, large handle, medium handle, small handle, and spindle are assembled in that order. And here's a sequence comparison table comparing both sequences. Sequence 1 scores more points than Sequence 2 for being better at fastening, joining, and testing sub-assemblies. Therefore, we like to go with Sequence 1.
Here we have the Functional Component Mapping Matrix, or FCMM, where the important branch-offs of the FAST diagram were charted against each of the parts. The most common functions here were to transfer power, generate torque, and control motion. The parts with the most functions listed were the handles, which included small, medium, and large. Here we have the bill of materials, where each individual part was charted with their quantity, material, manufacturing and assembly processes, and different variety form of costs, including the total unit cost. The total cost came out to be $11.72, and material costs were estimated based on similar parts. We assume production of 85,000 parts per year and $20 an hour for labor costs. The assembly processes were assumed to be manual except for the pre-purchase parts and fasteners. Here we have our quad chart classifications, where the parts were charted based on both functional importance and manufacturing/assembly costs. Fasteners and pre-purchased parts were excluded from this analysis. It can be seen that the parts with high functional importance and high costs were the drill housing, spindle, pinion, drill machine body, bevel gear, and the large and medium handles, while the only part with low functional importance and costs was a rivet.
From our FAST diagram, we see that our main differentiations for these groups are preventing fatigue, assuring comfort, and pleasing the senses. And from that, we get that the modules on this part are the crank, the handles, the drill housing, and the drill body.
The CAD for modules. So the CAD for modules we have here, updated design and the initial design. The initial design basically had the crank that's connected to the gear housing and the bevel gear and with a screw, and that way you can turn this crank and basically it applies the torque and everything to the hand drill torque. Here we have just one piece, which is just a piece of metal, sheet metal, that's connected to a fastener and a bevel and a spacer connected to the bevel gear and to the hand drill, and then you can just turn it around. Basically makes the updated version easier to assemble, and basically easier to mass produce. Common interface. Here we can see how they're all attached together. Right here, it's attached. We can see like how our thing is attached to the bevel gear, the updated model, and then here the crank, the old model is attached. How it is. And then for the PFADs, we can see the original one. We can go from the large handle, medium handle, bevel gear, bevel gear housing, and then we have two choices between the original crank and the new crank. And then we just need to attach the spindle, and we end up with each alternative design. And then for the new one, we just switched out actually the spindle and the small handle as to make it all even until the branching comes in the end. Goes from the bevel gear housing, the large handle, medium handle, spindle, and then the small handle. And that way we end up with each of either the original or the updated version.